In the last topic for this section, we're going to talk about something called direct translation and how it ties into algebraic expressions. So, in the previous chapter, we did quite a bit of what we call problem solving. So, problem solving is basically just math word problems. Sorry, there's a mosquito or something in here. My doors are open. Anyway, so when you're dealing with math and word problems, we typically call it applications or problem solving. And part of that, when we start to incorporate these ideas of algebra, is something called direct translation. Okay. So, as a definition, we have that direct translation is the process of converting words to math. And when you're dealing with algebra, the number one thing that you have to remember is that it is your job as the mathematician to assign a variable to some unknown value. Okay. So in the previous chapter, when we were solving word problems, we weren't really using algebra at all. We were just taking these ideas, we were adding, subtracting, multiplying, or dividing, and so forth. Now we're going to kind of like very gently incorporate this idea of algebra. So in the previous chapter, you did see this table. So the following table shows keywords and phrases that can be used for different operations. So we have a list of words that are really common, and this is not a complete list. This is just a list of really common words and phrases that can be used to indicate addition, subtraction, multiplication, and division. Okay, so let's take what we already know about problem solving and kind of throw it into this new world that we have of algebra. Okay, so example 3 says write, that should say an algebraic expression. That is definitely a typo. So it says write an algebraic expression for each phrase. Okay, so remember, our job as the mathematician is to assign a variable to the unknown. So let's just say, for consistency's sake, we're going to let x equal some unknown value. Okay. So for part A, it says a number increased by 5. We want to take our skills now that we kind of understand a little bit about algebra and we understand a little bit about problem solving, and we want to merge those two worlds, and we want to create an algebraic expression to represent this sentence. Well, we have a number. We don't know what that number is, so this would be some unknown value. All we know is we're taking this unknown number and we're going to increase it by 5. Well, increase by is a word that would, or a phrase that would typically be used to indicate addition. So all we have to do is take our unknown number, which we've already assigned x to be the unknown, and increase it by 5. So this right here, if we were to say this in words, we have some unknown value x increased by 5. Okay? For part B is always one that kind of flips students out, but you'll see twice a number, you'll see triple a number, you'll see double a number all the time. And when you see twice a number, thrice a number, 3 times a number, double a number, it just means multiply. Okay, so we want to take twice some unknown number. So we're going to let that unknown number be x. And then we want twice that. So we want 2 times x. So as silly as it is, imagine you want 2 times the amount of fries at McDonald's. That means you want twice the number of fries. It's the same thing. It's just meaning you want double that thing. You want 2 times whatever that unknown thing is. Okay? Now, for part C, we're starting to like ease our way into this world of algebra, okay? So when you're in algebra and you're dealing with a quotient, remember, quotient should right off the bat scream division to you, okay? So when you're dealing with a quotient, we typically write our quotients in algebra as a fraction, okay? So when you think quotient, think division, but think division as a fraction. So we're going to use that fraction form. So we want the quotient of a number. We don't know what that number is. This is our unknown. And 3. So basically, we want to take a number and divide it by 3. So we would take x and we would divide it by 3. And off to the side, I do want to say that this is not incorrect, okay? But in math, we generally use the fraction form. In algebra. Okay, so when we're dealing with that algebra in math class, when we have quotients, we write them as fractions, okay? So again, x with the division symbol 3, it's not incorrect, it's just not the best form. It's not what you're typically going to see. Okay, part C, subtracted from. We already know the subtraction is going to be here. They've laid it out quite literally in black and white. So we have 8 subtracted from a number. When you're dealing with subtraction, order absolutely matters. So you have to be really, really careful, okay? So we have 8 subtracted from. So we're taking 8 away from something else, and that something else is our unknown. So we have some unknown value. We're going to call it x, and we want to take 8 away from that. So the correct order here would be x minus 8. Okay, so do just use a little extra caution when you're dealing with subtraction. Okay, now let's look at part E. So for part E, we have the sum of 3 times a number in 4. So we've got a couple of things going on. So first of all, we have a sum. We have 3 times, and then we have some unknown numbers. This is our unknown, and 4. Okay? So a lot's going on here. First of all, sum. When you hear the word sum in math, you should automatically think addition. So at some point, we're going to be adding things together. Okay? Now, when it comes to what we're adding, we have 3 times some unknown number x. Well, 3 times is literally like 3 times 3 multiply. So we want to take 3 times this unknown number x. So we're going to take 3 and multiply it by x. And we want the sum of that and 4. So to this 3x, we just want to add 4. So really make note of the format here, the 3x plus 4, and how that translates back to those words that we have in this initial sentence. Okay? Now, just to throw your world completely into chaos, let's look at part F. Okay? Now, for part F, we have 3 times the sum of a number in 4. Well, you're thinking to yourself, gosh, that sounds a lot like part E. It sounds a lot like part E. It has a lot of the same parts as E, but it is not the same as E. So be really careful. The subtlety here is going to make a huge difference when it comes to the actual math. So here we want 3 times an entire sum. So if I want 3 times an entire sum, I would want to write that sum inside parentheses. Okay, so we do have a sum of a number and 4. So the sum of a number and 4 is just x plus 4, and then we want 3 times that entire sum, okay? So be really, really careful with something like part E compared to part F. They're both involved. They both have some things going on, so really read them carefully, understand how they translate to the math and how the math translates back to the words, but really try to see the difference in the two of these, okay? So that's direct translation. We've practiced with assigning some variables and throwing them into some kind of word problems, and we're going to see more of this throughout the semester. And then eventually we'll get to a chapter in algebra where we're going to do quite a bit of this, okay? So it may feel a little disjoint for now, but we're just trying to slowly ease you into the world of algebra.